Imagine this. You've got solar panels humming on your roof, right? Generating so much power you can run your entire home,
Hmm.
charge your electric car, and still have enough left over to store, maybe for those dark, demanding winter months.
Yeah, that's the dream for a lot of people, isn't it? True energy independence.
Exactly. But what if we told you that one solution you hear about a lot, seasonal hydrogen storage, might not be the big revolutionary answer everyone hoped for, at least maybe not for your home.
Right. It's a really hot topic, but
Mm.
the reality on the ground, especially residentially, might be different.
Okay, so let's unpack this. Our deep dive today is all about a really comprehensive study. It's titled Seasonal Hydrogen Storage for Residential On and Off-Grid Solar Photovoltaics Prosumer Applications. Revolutionary Solution or Niche Market for the Energy Transition Until 2050.
It's quite a title.
It is, and our mission here is to explore whether hydrogen truly offers, a wide-ranging solution for residential energy independence, or if it's maybe destined for a very specific, perhaps kind of unexpected niche.
Hmm. And we're digging into the research you shared, pulling out the key bits.
Yeah, the most important insights that impact your journey towards maybe getting off the grid or just cutting energy costs.
Okay, let's set the scene first. The idea of the prosumer.
Right. So that's someone who doesn't just consume energy, but actively produces it. Usually with rooftop solar PV, right? Photovoltaics.
Exactly. It's a growing trend. Makes sense.
But here's the core challenge. Solar PV is fantastic, but sunlight, well, it's seasonal.
Very seasonal,
Yeah.
especially the further you get from the equator.
Totally. So in many places, think higher latitudes, there's this huge mismatch between all the sun you get in summer and how much energy you actually need in winter, especially for heating.
Right. And this strong seasonality, as the study calls it, it really lowers your self-consumption ratio.
Explain that bit.
Sure. It's basically how much of the energy you make on your roof you actually use yourself in your home. If there's a big seasonal gap, you end up selling lots cheap in summer and buying back expensive in winter. Not ideal.
Got it. So you need a way to bridge that gap within the home itself.
Which leads to this idea of micro on-site sector coupling. Fancy term.
Yeah.
But it just means integrating everything, electricity, heating, maybe even your EV charging, into one smart system at home.
Making your house its own little energy hub.
Precisely. And that's where hydrogen often pops up in discussions
Yeah.
as a potential hero for storing energy across seasons.
Right. The idea being you take excess summer solar power,
Use it to split water with an electrolyzer, making hydrogen gas, H2.
store that H2 somehow. Maybe a tank.
Yeah, store it, compress it maybe. And then when winter comes, or you just need power.
You run the H2 through a fuel cell to get electricity back.
Exactly. And this study looked carefully at that whole setup.
Hmm.
The water electrolyzer, or well, a hydrogen compressor, HEP, the storage tank itself, AGS, and the fuel cell, FKC.
Okay. Now, what makes this specific study stand out? You mentioned it's quite comprehensive.
It really is. The scope is massive. It seems to be the first global analysis of these kinds of systems, specifically for residential seasonal hydrogen storage. That gap needed filling.
Wow. Okay. Global how?
It covers 145 regions worldwide. It looks ahead over 30 years, from 2020 to 2050, in 5-year chunks. And crucially, it uses hourly data.
Hourly. That's incredibly detailed.
It is. It gives you a really granular picture. And again, the focus is residential.
Mm.
Not huge industrial plants, but systems that might fit in or around your home.
And how did they figure out what works best where?
They used an improved model, the LUT Prosum model. It basically uses linear optimization.
Yes.
It crunches the numbers to find the most cost-optimal system for every single region and scenario they tested,
Okay. And scenarios included.
both on-grid, so still connected to the main electricity grid, and totally off-grid standalone homes. Plus, they threw in different electric car situations.
Like standard EVs.
Yep, standard battery electric vehicles, BEVs, but also vehicle-to-home, or V2H, where the car battery can actually power your house.
Okay, so super thorough, which brings us to the big reveal. What did they find about hydrogen?
Well, this is where it gets really interesting, like you said.
Yeah.
Despite all the hype,
Yeah.
the study's main finding for homes is pretty stark. Seasonal hydrogen storage offers only limited solution for bottlenecks.
Limited solution. So, not the game changer many thought.
Apparently not, at least not broadly. It seems it's not the universal answer for residential energy independence, cost-wise anyway,
Okay. So, where did it make sense in their models?
only under very specific conditions. Hydrogen systems only showed up in the cheapest solutions in high-latitude countries.
Like way up north.
Exactly.
Yeah.
Think North America, Northern Europe, Northwest Eurasia. Places like Finland, Iceland, Norway, Western Canada, even U.S. Alaska. Places with really long, dark winters.
Makes sense intuitively.
It does. But here's the kicker.
Yeah.
Even there, it was only when the system was forced to be off-grid.
Only off-grid, that's critical.
Absolutely critical. In their simulations, no region anywhere in the world found hydrogen to be part of the cheapest on-grid solution right out to 2050.
Wow, so if you're connected to the grid, forget hydrogen based on cost.
According to this optimization model, yes, batteries and grid interaction win out.
Can you give us an example of how big these systems were in those off-grid cases?
Sure. Finland, for instance, in those off-grid scenarios for 2050, had the biggest hydrogen storage capacity, calculated around 8,278 kilowatt hours of energy stored as H2 using the lower heating value.
That sounds like a lot.
It is a lot for a home.
Wow.
Shows how much energy they need to store to get through winter completely cut off.
Yeah.
But then you look at, say, Switzerland. In a similar off-grid case, it was much smaller, only about 143 kilowatt.
So it varies hugely. What about the electrolyzer and fuel cell sizes?
Also interesting, they were mostly kept really small, like the minimum allowed in the model, just 1 kilowatt electrical power.
1 kilowatt, that's tiny. Like a kettle?
Pretty much. Which suggests they aren't being used for, flexible power on demand. It's more like a slow, steady, maybe baseload trickle.
Even though they might run for many hours, you mentioned high full load hours.
Yeah, exactly. The electrolyzer might run thousands of hours a year, like up to 6,433 hours in one Russian region, but it's just running at that low 1 kilowatt rate, slowly building up that hydrogen store.
Okay. So if hydrogen is niche, mainly for extreme off-grid situations, what is the winner for most homes wanting to use their solar better?
The study is very clear on this. Globally, PV and battery systems offer the best cost advantage for the majority of regions.
Solar panels plus batteries, that's the combo.
That really seems to be the economic reality for most residential situations right now looking forward.
So PV plus batteries, maybe with efficient heating.
Exactly. Things like heat pumps for heating. The study found that combo is the most economic choice for most places.
Cheaper than just buying from the grid.
Often, yes. It can even achieve lower costs than full grid supply in off-grid mode for most regions by 2050.
And for on-grid?
For on-grid, the economics get really compelling. They reckon by 2035, nearly 97% of regions can hit grid parity.
Meaning your own solar and battery system costs the same or less than grid power.
Yep. And by 2050, it's 100% of regions for on-grid scenarios. Solar plus battery becomes the default economic choice almost everywhere if you're grid connected.
And what about the electric car factor?
That helps too. Just having a standard EV can lower costs by smoothing out your energy demand. But the vehicle-to-home option, V2H,
Where the car powers the house.
right, that V2HC capability, as they call it, can sometimes make a separate home battery totally unnecessary or superfluous. Your car is the battery.
That's a powerful idea.
It really is. Of course, system sizing depends on grid connection. Off-grid needs bigger PV arrays and bigger batteries, obviously, because you have no backup.
Okay, so the numbers seem stacked against hydrogen for most homes, but why? We hear so much about hydrogen being crucial for the energy transition. What makes it struggle at the small residential scale?
Yeah, that's the key question, isn't it? This study points to two really fundamental problems for residential hydrogen, even looking ahead with projected cost drops.
Okay, number one.
High investment cost, especially for the electrolyzer and the fuel cell. Even with optimistic price reductions by 2050, these components are just expensive when scaled down to house size.
Right, economies of scale aren't there. And number two,
This one's maybe even bigger, low efficiency. The whole cycle, electricity to hydrogen, store it, then hydrogen back to electricity, it wastes a lot of energy.
how much?
Think about it like this. For every 1 kilowatt hour of valuable solar electricity, you feed into the electrolyzer.
Yeah.
This study found you only get about 0.22 kilowatt hours back out of the fuel cell to actually use in your home.
Wait, only 22% back?
Roughly, yeah. That's a round-trip efficiency of just 22%. The fuel cell itself is only converting the hydrogen to electricity at about 37% efficiency electrically.
Wow. So you lose almost 80% of the energy.
In that conversion process, yes. That's a massive hurdle. So the idea that H2 could really boost your self-consumption in winter by storing summer energy efficiently,
Doesn't really hold up.
the study said that could not be confirmed. The efficiency losses are just too great at this scale.
It really is a paradox then, because we do hear constantly about hydrogen for industry, heavy trucks, maybe grid balancing.
Exactly.
So what's the disconnect? Why is it potentially viable large scale, but seemingly not small scale residential?
That's the micro versus macro distinction the study highlights. Microsector coupling, that's your house,
Hmm.
versus macrosector coupling, the whole energy system.
Okay.
For micro residential systems, those key hydrogen components, the YOL and FC, are just way more expensive per unit of power per installed kilowatt compared to big industrial scale versions.
No economies of scale again.
Right. And at the macro level, the entire grid offers much more flexibility. You have diverse generation, interconnection, potentially large-scale storage options that are more efficient than small hydrogen tanks.
And the big hydrogen projects aren't always about storing electricity seasonally, are they?
Often not. Many large-scale electrolyzer plants are about indirect electrification,
Yeah.
making hydrogen as a clean fuel or feedstock for industries that are hard to electrify directly,
Yeah.
or maybe making other synthetic fuels. It's not primarily about storing electricity to put back onto the grid seasonally, though that's discussed too. The drivers are just different.
Okay, that makes sense. Now, the study also mentioned something else, a potential bottleneck with materials, iridium.
Ah, yes, that's another layer to consider. Many of the efficient electrolyzers, the PEM type, and some fuel cells rely on platinum group metals, including iridium.
Which is rare and expensive.
Very. And the study looked at future projections. While it might be technically possible to make enough H2 systems for many homes if we get much better at using less iridium,
But
but the total global demand for electrolyzers for everything, industry, transport, grid, could be huge, like 5 to 17 terawatts by 2050.
terawatts, that's enormous.
It is. And if that happens, residential hydrogen, even if widely adopted where it makes sense off-grid, might only be a tiny slice of that market, maybe 1% to 20%, which raises questions about supply priorities and costs.
So another challenge, did the study suggest other research areas?
Yeah, definitely. Things like looking at real-world grid limitations for feeding power back, digging deeper into the availability of all the raw materials needed, not just iridium, and of course, exploring alternative technologies that might avoid these issues.
Okay, so let's try and wrap this up. What's the main takeaway for you, the homeowner? Maybe dreaming of that energy independence.
Well, based on this deep dive into the study, for most residential PV prosumers, the path looks pretty clear.
Which is?
Solar panels plus batteries.
Hmm.
That combination seems to be the most economic and effective route for the vast majority. It can often make your home cheaper to run than relying just on the grid.
And seasonal hydrogen storage.
While it works technically, it really seems to be a niche market solution, primarily for those specific off-grid homes in high-latitude places, and likely driven by factors beyond just pure cost optimization.
Right. So we've taken a deep dive into seasonal hydrogen storage for residential on and off-grid solar photovoltaics prosumer applications, revolutionary solution or niche market for the energy transition until 2050.
Quite the journey through that data.
Indeed. So here's a final thought for you to ponder. If the economics, the pure cost optimization, points so strongly away from hydrogen for the typical home, what other reasons, what non-economic drivers might still make it essential for some?
Yeah, things like extreme resilience, perhaps, if you're in a really remote area prone to long outages.
Or maybe just the desire for absolute 100% self-reliance, completely independent of any grid cost aside. Or even, just the fascination with pushing the boundaries of home energy tech.
Could be. It suggests that while batteries might be the mainstream answer, hydrogen could still be a vital, specialized piece of the future energy puzzle for certain people in certain situations. Something to think about.